On the AMD Platform AM4, the motherboard VRM controller is responsible for communicating the actual CPU voltage, current, and thus power consumption to the processor itself. The CPU then employs this information to tweak its operating variables so as not to violate default limits/design specifications. Alas, some motherboards lie to their CPU. If the former declares a power draw higher than the real one, the latter believes it consumes more watts than it truly does. Hence, the processor will wrongly restrain itself. Conversely, if the former declares a power draw lower than the real one, the latter believes it consumes less watts than it truly does. Hence, the processor will wrongly free itself. Now we are going to answer 3 questions. 1. Why do they lie? 2. How much do they lie? 3. How can we counteract their lying? The response to the first query is simple. Whereas an overstatement and understatement of power could both be a genuine mistake, the second is more likely a sly exploit used by the motherboard manufacturer to achieve a performance edge over the competition. The entity of this benefit depends on how much they make their motherboards lie. To answer question number 2, you should learn how to read the power reporting deviation metric in HWiNFO. As you can see, the reported value is all over the place with a CPU in idle state, and so must be disregarded. In fact, it's only valid with a stock CPU in a specific and almost full load state. Pay attention now, because what I'm about to say is paramount. By stock CPU, I mean you must disable any kind of overclocking. The quickest way to do so is reset your BIOS settings. By specific and almost full load state, I mean you must use the Cinebench R20 multi-threaded workload and nothing else. No R23, Prime 95 or any Limpac-based stress test. Therefore, open Release 20 beside HWiNFO with its polling rate set to 100 milliseconds. Now click Run and the Reset Sensors button as soon as the rendering really starts. Wait until the CPU renders the last vertical line and press Win plus Print Screen keys halfway through. Now. Next, open the screenshot. And write down these 5 values: average core clocks, CPU TCT-LT die, CPU PPT, and power reporting deviation, obviously. Oh, don't forget the Cinebench score. Finally, repeat this test at least 9 more times and compute the mean of those 10 deviations. In case your average power reporting deviation is 100%, well, there's no bias at all, so you can stop watching this video. If it sits between 90 and 110%, that's regarded as a reasonable error. Negative below 100, namely an underestimation, and positive above 100, namely an overestimation. You could stop watching too, or not. Lastly, if it's less than 90 or more than 110, that's absolutely an intentional inaccuracy, and you should continue watching. In my particular case, my Mobo is reporting a CPU power consumption that's only 78% of the real one. To counteract this inaccuracy, the first thing you need to do is update the BIOS to the latest version, since the manufacturer might have already made amends for their deception. In case they did not, you'll have to remedy it yourself, as follows. Open Ryzen Master and take note of the default PPT value for your CPU. It represents the maximum power consumption allowed per specification. Now we are going to use your PRD and PPT values as terms in two simple proportions. The first to expose the true max CPU power consumption allowed by our dishonest motherboard, and the second to pinpoint the PPT value that indeed realizes the expected power consumption. Proportion 1. PRD 78% is to PPT 88 watts as 100% is to X. Thus, X is 112 watts. Basically, my MOB lets my CPU to consume a maximum of 112 watts instead of the 88 watts as per spec. That's a difference of 24 watts. Please note this doesn't mean that my CPU will surely consume 112 watts, because other limiters may kick in before reaching that power draw. But still. Proportion 2. 100% is to PPT 88 watts as PRD 78% is to X. Thus, X is 69 watts. In other words, I must set a PPT of 69 watts in BIOS in order for my CPU to consume a maximum of 88 watts, as per spec. To accomplish this, enter BIOS and find the AMD overclocking entry, then select Precision Boost Overdrive Advanced, PBO Limits, PPT 69. As an alternative, find the AMD CBS entry and select XFR Enhancements, Precision Boost Overdrive Manual, PBO Limits, PPT 69. In both menus, if you want, you can also specify the default TDC and EDC values, which Ryzen Master state next to SoC power, here. As you might have guessed from my answer to the third question, yes, all in all the motherboard is still lying to the CPU, but at least it's an untruth that doesn't benefit or hurt anyone. To conclude on a high note anyway, rerun Cinebench R20 10 times and compare before and after conditions. At the cost of a few benchmark points, we have seriously reduced the CPU temperature. But you may ask, is this difference in performance significant? A good question for another time. Farewell for now.